Welcome to the 2021 Materials Research Society Fall Meeting. The Fall Meeting events continue virtually this week with more great symposium sessions, keynotes, and award talks, and much more. This is MRS TV. Welcome to the fifth and final episode of MRS TV. We hope that you have all enjoyed this 2021 fall meeting, and we encourage you to go check out the previous episodes of MRS TV on both the meeting platform and online if you missed out on any of the previous programs. For our last episode, today we are joined by MRS PostDoctoral Award winner Zhijie Chen and Buck Robinson Award winner Stafford Sheehan. We also finish with the remaining research centers and institutions that are making waves in materials science research, so be sure to stay tuned. But first, we are excited to welcome Susan Bernal Lopez on how to cement a low-carbon future infrastructure.
Well, thank you very much for having me.
Congratulations on having been named to deliver the 2021 MRS Fall Meeting Kavli Foundation Early Career Lectureship. Can you give us a little bit of a preview of what exactly you will be talking about?
Well, I will say my lecture will be a mix of two components. First, I would like to get people excited about cement and concrete, sharing some of the important facts, for example, that concrete is the most widely used material on the planet. And then the second part of my talk will be showcasing some of the research that I've been doing with my research team, particularly in a new low-carbon type of cement that is called alkali-activated cement.
Concrete and cement aren't necessarily the first materials that someone thinks about when thinking about sustainability. What are some of the advances in these materials that will lead to more sustainable infrastructure development?
That's a very important question, and I will say briefly that we can kind of cluster these in three main topics. So one will be, for example, making more sustainable cement. So shifting from this like monoculture of using Poland cement for everything that we need towards having like this toolkit of cement. I will say that the second big branch towards sustainability will be using cement better when we produce concrete. So optimizing how much of this valuable resource we use to produce concrete is another approach to sustainability. And I will say to finalize, we need to improve how we use concrete in infrastructure. So there have been tremendous developments over the past decade in using bio-based materials or using different composites type of infrastructure.
Well, infrastructure has certainly been in the news as of late, particularly here in the United States. With significant investments in infrastructure likely on the way, how do we ensure that the very latest science in low-carbon cements are included in those investments?
In my personal opinion, the first thing is getting more engagement and the communication between researchers and industrialists and even politicians is absolutely key. But the other thing is we also need the policy and the standards that will enable us to use these new materials, for example, in construction. So we need this like scientific development of these new technologies to go in hand with the development of these standards and testing methods and policy that will enable us to put it in place.
What are some of the obstacles to overcome in implementing these new discoveries? Are there still technical challenges, or are the obstacles more political or societal in nature? Or maybe a combination of all of those?
So I will say that overall, in my personal opinion, first is a lack of understanding of the science behind how these materials actually are produced and performed. So that creates a little bit of fear from some people about change. But also I will say that the people making these decisions to adopt new sustainable technologies need to also understand the complexity of change that is required for a vast industry like the cement sector. So when we say, oh yes, let's move to sustainable technologies, we need to also take into consideration the tremendous impact from a financial point of view, from a business model point of view. that will have for these industries.
All right, thank you so much for your time today. Certainly appreciate it.
No, thank you very much for inviting me. It was really enjoyable. Thanks.
The Institute of Structural Materials, ISM, at Swansea University is a unique facility that offers testing and characterization of metallic materials and advanced composites. Let's take a visit to see what makes it so special.
The Institute of Structural Materials is based around the microstructure property relations of high-performance materials. We're interested in mechanical characterization, mechanical testing of different materials.
We have a wide range of mechanical test frames here that can do all manner of different things, such as fatigue testing, creep testing, thermal mechanical fatigue testing, powder interlayer bonding, and that's unrivaled across the world.
It combines a commercial test house, which is called SMART, and also we have a number of academics and research students who can then interpret the results that are generated from the test house.
We also have an array of different non-invasive measurement techniques for temperature and in situ analysis. These are pyrometry, thermography, digital image correlation, and acoustic emission.
We've got a track record of success over a number of years and have delivered research programs in aerospace, automotive, nuclear. I think we're well placed to adapt to the future materials challenges we're going to see over the next 10 years.
And now for another trip across the ocean to Ireland, where the Advanced Materials and Bioengineering Research Centers partners leading researchers in materials science with industry to help bring ideas from the lab to the market.
AMBER stands for the Advanced Materials and Bioengineering Research Centre. AMBER is hosted within Trinity College, Dublin.
AMBER's mission is to carry out world-leading material science and partner with companies really to translate research into commercial value.
AMBER has it all. It's got the faculty and the staff, and I'm finding a lot of good people to work with here that I may not have found in any other institution.
The collaboration between AMBER and industry is really important. We've had licenses which have gone all the way from our laboratories onto supermarket shelves.
We need a partner like AMBER to help us investigate many materials aspects so that we can ultimately make informed decisions about the future of semiconductor technology.
AMBER is an important partner for us because the relationship is so productive. From the management of the programs to the engagement with the scientists.
The Materials Research Society is proud to share our diversity, equity, and inclusion aspiration that reinforces our long-standing organizational values. The Materials Research Society embraces diversity, equity, and inclusion by actively engaging our diverse global membership, supporting the careers of underrepresented researchers, and investing in community actions to address bias and end inequities. This aspiration reflects our commitment for a welcoming environment in which our members can advance our field with their research and innovations.
Empowering members in underrepresented groups through meaningful educational and career opportunities supports growth of the materials research community. AMRES is actively engaging our diverse global membership through initiatives such as the PREM Scholars Summit, Women in Materials Science and Engineering programs, the UREM Student Science Writing Program, as well as skill building and career discovery webinars. The MRS Diversity and Inclusion Fund and the MRS Developing Country Membership Program make the Society more accessible to researchers around the world, and our advocacy work and special interest groups allow all materials researchers to have a home in the Society. MRS stands firmly against racism, discrimination, inequality, and all forms of bias. Supporting this aspiration are various programs and alliances, including unconscious bias webinars and Train the Trainer resources. MRS is a founding member of the Inclusive Graduate Education Network and an inaugural founding member of the Society's Consortium on Sexual Harassment in STEM. Both of these groups promote equity, inclusion, and professional and ethical conduct. Learn more about MRS's longstanding and new DE&I programs and initiatives and how these are supporting the Society as we work together to fulfill our DE&I aspiration statement.
Your contributions are vital to achieving our aspiration. Please contact us via our website at mrs.org/aboutmrs/contact-us or email us at volunteer@mrs.org to help MRS make a difference in the materials community.
Dr. Zhijie Chen of Northwestern University is an expert in the fields of porous materials, nanochemistry, and supramolecular assembly. Congratulations, Dr. Chen, on having been named a winner of the 2021 MRS PostDoctoral Award, and welcome. Thanks for joining us.
Thank you very much. It's my great honor to receive this award, and it's nice to be here.
You will participate in the Award Lightning Talks on Tuesday, December 7th, where you will present precise synthesis of porous crystalline materials for clean energy and nerve agents destruction. Can you give us a preview of your talk?
Here in this talk, I will show the design and the synthesis of an ultra-porous MOF. It's called NU1501, which shows impressive balance gravimetric and volumetric storage performance for this gas. And in the second part, I will report a generalizable and scalable approach for the integrating MOF and polymer base onto the textile fibers for the practical destruction of nerve agents.
What would you say are some of the devices or applications that might result from your work?
Yes, as I mentioned previously, some of the potential applications can be hydrogen or methane storage and nerve agent destruction. These type of MOF materials have very high surface area. You can envision that 1 gram of MOF can contain surface area larger than a football field. Because of high surface area and the porosity, the confined nanospace can be used for the efficient storage of gases. Also, because of the nanoporous nature of MOF, they can absorb a large amount of water from air. Combined, it is possible to use the MOF composite materials for the hydrolysis of nerve agent without needing the liquid water.
Why did you enter into this particular field in material science?
Yes, I first know about the porous materials and supramolecular assembly when I was an undergraduate student at Shanghai Jiao Tong University in China. So I further to study porous assembled frameworks materials when I was conducting my PhD research in Professor Mohammed Idaldi's group at King Abdullah University of Science and Technology in Saudi Arabia. I mainly focus on the study and the development of reticular chemistry. And this type of chemistry allows the precise assembly of porous framework materials at the molecular level precision. And that's how I enter this particular field.
What's next for you after your postdoc assignment has concluded?
So, my next phase is to start my independent career as a PI. And in the future, I will need to adjust more diverse challenges. For example, applying fundings from different sources and the teaching obligations and undergraduate and graduate level and conducting fundamental research. Particularly, I would like to share my diverse scientific experience and communicate with young students.
Well, once again, congratulations and thanks for your time today.
Thank you very much.
And now for our final visit today, let's head to Virginia Tech's Macromolecules Innovation Institute to see how they have been a hub of transdisciplinary materials science research since the 1980s.
The Macromolecules Innovation Institute is recognized globally as a go-to place for macromolecular science and engineering.
I really enjoy working at MII because I get to work with material scientists and chemists to create materials for the next generation additive manufacturing systems. The transdisciplinary research enabled by MII has really transformed my research in my research lab.
I'm not a traditionally trained polymer chemist, but the day that I joined Virginia Tech, I realized I can use so much resources that's already built at Virginia Tech on the polymer research areas.
We're working across campus with multiple researchers who do things as disparate as mechanical testing, electron microscopy, and being able to combine all these things together really lets us advance our materials much more rapidly.
When we bring in junior faculty and students and postdocs, they come here and they recognize quickly that they need to be the leaders of tomorrow.
As tackling climate change becomes an ever more important priority, Stony Brook University's facilities are responding to the cause. Let's see how.
Stony Brook has traditionally been a leader in material science. More recently, the focus has switched to studying the problem of our generation, climate change.
The challenges that we're taking on are large challenges. These are difficult questions. Collaboration is absolutely critical.
We are developing energy storage technology, materials that will enable nuclear fusion, and the infrastructure for a clean hydrogen economy.
Fundamentally, a lot of that comes down to understand your materials' properties and how they function.
We are educating the next generation of engineers to go out there, work in these large interdisciplinary teams, and be prepared to solve these challenges in the coming decades.
The students, they build that connections of, yes, fundamental science matters. Yes, our science is directly connected to making those technologies better. And it's incredibly exciting to be part of that.
Welcome, Stafford Sheehan. You're here to discuss your work with Air Company. So thank you so much for being here with us today.
Yeah, thank you very much for having me, Stacy.
Congratulations on having been named the 2021 Nelson Buck Robertson Science and Technology Award for Renewable Energy.
Thank you. I'm really honored to be selected for that award, and really thankful for everybody at MRS that made it possible.
And so you are co-founder of Air Company, and your company has developed technology to convert carbon dioxide into alcohols. What led you to this development?
What led myself and my coworkers to this development was really the desire to remove carbon dioxide. Usually when you're making a product, you're trying to make something, not take away the reagents. In the case of carbon dioxide conversion, you're doing it because you want to use carbon dioxide as a feedstock to turn it into something better for the world than climate change.
So what are some of the products that have come of your research?
We turn carbon dioxide and water into alcohols using renewable electricity. The alcohol that we separate out from our product mixture is ethanol to make our consumer products. And there are a lot of things that you can make with ethanol. Ethyl alcohol is, it's in your gasoline, so whenever you drive a car, you're burning it. It's in sanitizers that we're all using and are ubiquitous today. And it's in products like vodka, spirits, fragrances, luxury products. So we turn carbon dioxide into ethanol, and we use that ethanol as we're scaling up our technology to make products like, this is Air Company's vodka. So we 40% ethanol in this liquid. This is our sanitizer product, 80% ethanol in this liquid, and the ethanol comes from carbon dioxide.
So kind of taking a look into the future with this related technologies, how much can these contribute to the reduction of greenhouse gases?
So I leave a lot of that up to climate change experts and the people who study that for a living. There are some publications out there that cite numbers around 10% of global greenhouse gas emissions could be reduced or mitigated by making products from carbon dioxide using carbon dioxide utilization, in the manner that we do, so making chemical products from carbon dioxide. So 10% may not sound like a huge number in a vacuum, but when you're talking about a problem as big as climate change, 10% is billions and billions of tons of carbon dioxide, and is a really significant impact toward stopping the increase to global average temperature.
So just kind of wrapping things up, so what is the next steps for you guys?
Well, our consumer goods are really just the proof point for our research and development to scale our technology. We're really scaling our technology to be able to tackle commodity alcohol and fuel markets. So our ultimate end goal is to be able to deploy this on the world scale so that we're able to sequester hundreds of millions of tons of carbon dioxide in very, very large plants.
Well, thank you so much, Stafford Sheehan, for joining us today, and good luck to Air Company and all of your future endeavors.
Thank you very much, Stacy. Appreciate it.
The Materials and Manufacturing Directorate at the Air Force Research Laboratory develops materials, processes, and manufacturing for a variety of aerospace uses. Let's take a look.
Welcome to the Air Force Research Laboratory's Materials and Manufacturing Directorate. We invent the stuff that makes the future for the Air Force and the Space Force. Our mission's unique in that we have an outstanding cadre of expert scientists and engineers that push the state of the possible to ensure the materials are available for our warfighters, as well as the manufacturability, the inspection technologies, and the sustainability of those technologies, so that when one of our men and women in the Air Force or Space Force uses something, they have confidence that that technology is going to deliver what they need it to deliver. We're really excited about bringing together very diverse teams, not only material scientists, but chemists, physicists, information technologists, data analytics. Those are all the types of technologies that need to come together to ensure we can continue to develop new stuff that will make the future.
The Macromolecular Chemistry Group at Martin Luther University in Germany is dedicated toward the synthesis of novel polymers. Their aim is to generate improved materials for everyday use. Let's see how.
We address the challenge to increase the sustainability of polymers by developing novel chemical concepts to improve their lifetime and recyclability.
Batteries are the most promising storage devices, for example, for reaching clean mobility. We are developing novel self-healing polymer electrolytes for the new generation high-energy density lithium-ion batteries to meet emerging demands in electronic, automotive industry and other energy storage systems.
We are designing, synthesizing and analyzing polymers, representing key molecules which are widely used in society. These large molecules are known as structural materials in automobiles or aeroplanes, but are used in biomedicine, modern energy, or information technology as well. We invite you to come here to conduct research in polymer sciences in our laboratories.
That's all for our final episode of MRS TV. We thank you all for joining all of the great sessions, presentations, and special events that the MRS Fall Meeting has to offer. Remember that you can always go back and watch any of the recorded programming by searching the full agenda section on the platform, and you can always watch all of the MRS TV episodes on the MRS TV playlist. Happy holidays, and we can't wait to see you next time.
The University Chapter Program is a passionate and talented network of students from 130 universities in 27 countries. The program fosters an environment for collaboration and open exchange of ideas across all scientific disciplines. Congratulations to the newest MRS University Chapter, the University of Mongolia. If you are a student or faculty member and are interested in starting a chapter at your institution, visit the University Chapter website, mrs.org/universitychapters, to learn more. MRS now offers a free one-year dues renewal option for recent doctoral graduates. This offer, available only once per member, is designed to support our next generation of researchers as they transition from student to career professionals, and will include all benefits and advantages of MRS membership. The next membership cycle begins January 1. Check your inbox. Details will be sent by email to those who are eligible.
MRS engages members across generations to advance their careers and promote materials research and innovation. Whether you are seeking a new career opportunity, committed to creating more inclusive and equitable environments, or gaining recognition for educational and career achievements, MRS is here to support your career advancement goals. Free webinars and virtual workshops are offered year-round, covering a wide range of topics, from preparing for a job search to getting your work published, to understanding unconscious bias, and so much more. Learn more at mrs.org/careercentral. Don't just read our journals, contribute to them. By submitting your work to an MRS journal, you'll reach a global audience and have an impact that will extend for many years. MRS publishes cutting-edge research, perspectives, and review articles along with books and textbooks. Visit booth 617 in the exhibit hall Tuesday through Thursday to find the MRS journal that meets your materials topic and stage of research. Meet with commissioning editors, learn about new author services and discounted open access for MRS members, and more.
Nominate an outstanding paper published in 2021 for JMR's 8th Annual Paper of the Year. The award recognizes excellence in advancing materials knowledge through written scholarship. The nomination deadline is January 19. The award will be presented at the 2022 MRS Spring Meeting. Since 1990, the MRS Spring Meeting has been held in only 2 locations, San Francisco and Phoenix, and has always been tied to Easter weekend. All of that changes in 2022, when the MRS Spring Meeting goes on the road. Honolulu, San Francisco, and Seattle have been selected because they are considered Tier 1 locations for meetings and conferences. They are diverse metropolitan areas and premier destinations for arts and entertainment. These rotations will foster regional and student attendance. We hope you'll join us this May in Honolulu.